In this video, I'm going to show an interesting theorem. We are told that set S, and set T are bases for Rn. And let the transition matrix, or let that symbol be the transition matrix from the T basis to the X basis. Now, this matrix is non-singular. That's one thing we want to show. And this matrix is the transition matrix from S to B. It goes in reverse order. So we want to show two things. We want to show that this matrix is non-singular and that its inverse goes in the other direction. Goes from the S basis to the T basis. And the first thing we're going to do in the proof, we're going to state how we're going to do this. Okay, we will show that the null space of this transition matrix contains only the zero vector. Contains only the zero vector. Okay, so let us show that. Suppose for little v in Rn, we have the following. That are the transition matrix from T basis to S basis of V in the T basis, the coordinates of V in the T basis is 0. Okay, and now we want to show that that's the zero vector in Rn. What else can it be? Okay, so then we have the following. P from the transition matrix from T to S of V of T is equal to Vs, hate notation. P, let me just call that P for short, of V of T, this equals the coordinate of V in the basis S. But by our assumption, this is the zero vector in Rn. Okay. So let us look at what V can be. Let us look at what this V can be. In set S, V could equal to A1V1 plus A2V2 up to plus ANVN. Notice that these vectors are coming from the set S. They're coming from the set S. Okay, but this is nothing more than, well, how do we say this? Okay. So this implies that A1, A2, just the scalars, well, that's V in that's the coordinates of V with respect to the S basis. But we know that this is 0. This is 0 in Rn. This is the zero vector in Rn. But the zero vector in Rn is obviously all zeros. Say A1 is 0, A sub 2 is 0, A sub n is 0. So copying this down with the updated information, V is 0 V1 plus 0, V2 all the way to 0 times Vn. Well, that's just the 0 vector. That's just the 0 vector in Rn. Hence, the vector v in there with respect to the basis t is also 0Rn. That's our immediate result. Now we have the following, and this is where it all comes together. Then the homogeneous equation, well, let's call it system. The homogeneous system, the transition matrix from T to S of x equals 0, has only the trivial solution. Has only the trivial solution. But that means that this has an inverse. Hence, P from the transition matrix from T to S is non-singular, which is one of the things we wanted to show. That is just super. But now, if we multiply, we're multiplying PS T of VT, VT equal to VS, but on the left, let's not forget we have to state that by the inverse, because we know the inverse exists now. The inverse of the transition matrix from T to S. We get, well, when we do that to this side, we get P inverse from T to S of the coordinate vector V in set S. And when we do it to the other side, well, you know, the P is going to cancel out. We just get VT, the coordinate of vector V in the T basis. Okay. V. So we're done. Let's just state what we have. That is this P inverse from T to S is just what we want. It's the transition matrix from the S basis to the T basis. And that is the second thing we wanted to show. And the last, which means this theorem has been proven. Don't memorize this stuff and don't accept anything your teacher tells you. I am by no means saying your teacher is wrong. I'm just saying don't believe a word that your teacher says. Go home, think it through, and conclude, yep, my teacher's right. Understand it, stop memorizing. If you like videos like this, please subscribe to my channel. Otherwise, don't watch any more of my videos. Watch and learn. See you in the next video.